Welcome everyone to our lesson on connected rates of change. Right, so what is the idea of connected rates of change? So you may be given that there are two variables, okay, x and y, and they are both varying. Okay, let's say they are varying with time. Okay, so we have variable x, variable y, and then another variable time, okay, t. So these three variables, we want to connect them, okay, in a single equation. How do we do that? We use chain rule, okay. So it's of this form: dy dt, be careful, it's not dx, okay. So dy dt is equal to dy dx times dx dt. Right, so since you are new to this, let me help you to know a way to remember this, okay? But you don't actually even need this formula. You don't need it. You don't need to have this formula, I mean, off mind, okay? You don't need to, because the question itself will tell you what to do. But this is what you need to know. This is the first letter, or I mean symbol that you see, okay, dy, that should start your formula. That should start. Then dt should be the last thing, okay, right? So that get it this way: the first starts and then the last ends, okay. Then the new variables that you'll be working will be diagonally equal, all right? So the x here, the x there. That is all that you need to know. So this starts, that ends. Whatever is in between, we'll figure it out when the question is given. Right, so let's start with the first example. So we have this variable x and y are connected by the equation y is equal to x squared minus 5x. Given that x increases at a rate of 0.05 units per second, find the rate of change of y when x equals 4, all right? So like I said, we don't need any of the questions, the formulas. Just, I mean, let's get it straight from the question, right? So first, let's get our data, important things from the question. We need the equation, okay? Y is equal to x squared minus 5. Then we also need to understand this statement that x increases at a rate, okay? If x is increasing at a rate of this per second, okay? So x is increasing per second. That means that is dx dt, okay? Because second is measured in time, okay? Time is measured in seconds. So we know that this will be dx dt, right? So we know our equation, we know dx dt to be equal to 0.05, all right? Then what are we to find? We are supposed to find the rate of change of y, okay? So we are looking for dy dt, okay? dy dt, and then x equals 4. So from the equation, like all these things that I spoke about, yes, I've stated all of them here. So that is all that you need from the equation. Now, if you are told to find dy dt, then we would work with dy first and dt will end, all right? But what should be the middle one? I know I've written dx, but how did I know that? It is because the y is given in terms of x, okay? So when I differentiate the y with respect to x, I have dy dx. That is why dx is coming here. So as soon as you write dx here, put dx there, right? Good. So we know dx dt, that is 0.05, but what we don't know is dy dx. So let's go and find out from the curve, okay? So let's differentiate this. So when we differentiate, we have 2x minus 5, right? So we need to find this gradient at x equals 4. So let's look for that. So at x equals 4, divide dx is what? Is 3, right? So we just put 3 here, and then we put 0.05 there, right? So therefore, dy dt is equal to 3 times 0.05, and that would give us 0.15, okay? So while x is increasing at this with respect to time, y will be increasing at that with respect to time. Let's consider another example. So this is a bit different, so let's pay attention here. A square has sides of length x centimeters and an area of a cm squared. Okay, the area is increasing at a constant rate of 0.2 meters per second squared. Okay, sorry, centimeters squared, and then s raised to the power -1 is the same as centimeters squared per second, right? So we are supposed to find the rate of increase of x when a is 16, right? So when you are given a question like this, all that you need to do is to come out with the important things from the question. First, a shape was given, a square, and it has a length of what, x, and it has an area of a squared. That means that, remember, a square has all lengths being equal. So the area is just going to be x times x, and that will give us x squared, all right? Good. Then we also told that this area called A is increasing at a rate of this per second. That should tell you that it is the A dt, okay? The A dt is giving us 0.2, right? And then they said that the area is what? Is 16, that's all. Well, and what else? We are supposed to find the rate of increase of x, all right? So we are looking for the x dt, okay? The x dt. So I've repeated the salient points from the question, right? So if we are looking for the x dt, then using the chain rule, it will give us this, okay? But how did I come up with this? Like I said, the x will be the first and then the t will be the last, okay? So what comes in the middle? Don't worry, you would find out from the rest of the question. We are given a equals what? We are given a equals x squared. So when we differentiate the area with respect to x, we'll get dA dx, right? dA dx. That means that we would, the next variable we are looking for is dA, all right? So put the a here, put the a there, and we are good to go, right? So now let's solve. So we differentiate this and we get 2x, right? No problem. But what is a? A is 16. Okay, but we also know that a is x squared. Good, so we can equate x squared to 16, and then we solve for x. Now I know that you might want to say x is plus or minus 4, which is correct, but we are talking about a square. A square can never have a negative length, so we just work with a positive and save time. So now that we know that x is 4, we can find the gradient at x equals 4. All right, now the equation is dx dA, okay? Dx dA, but what do we have here? We have dA dx. So if you want dx dA, it means you flip it, okay? Turn it upside down, and that will give us 1 over 2x. Why? Because this is over 1, okay? Every whole number is over 1. Okay, so there's over 1 here. So when you flip it, you have 1 over 2x. Then you multiply by dA dt, and our dA dt is 0.2, right? So all that you have to do is to put 4 at the place where you find the x, okay? So at x equals 4, your dx dt, that is this, just put 4 there, and then you have 0.025. all right? So when the area is increasing at this rate, the length, that is the x, which is the length, will be increasing with respect to time at this rate. Right, so our final example, we have a solid metal cuboid. Okay, so pay attention to the shape or the object that you'll be given. Okay, so it's a cuboid. We don't care whether it's metallic or it's plastic or whatever it is. All that we need to know that it is a cuboid. Okay, so it has dimension x by x by 5x. So since this is a solid, okay, we should be able to find the volume easily. All right. Okay, so that'll be this times that times this. That'll give us 5x cubed. Okay. Right, then we are told that this cuboid is heated and then the volume expands, okay, at a rate of this. So if the volume is increasing at this rate with respect to time, that's where the seconds is coming from. It means this is dv dt, okay, dv dt. Then we are supposed to find the rate of increase of what? X. So that is the x dt. So let's write the salient points from the question. Right, so from the question we know that the volume is 5x cubed, and that is this times that times this. Okay, then we also know that dv dt is giving us 0.5. Then we said x equals what? 4. What are we to find? The rate of change of x. Okay, the rate of increase of x, and that is the x dt. Right, so let's get started. So if we are looking for the x dt, then that means that it is the x starting and then dt ending. But what will be in the middle? We were given an equation. In fact, we came up with the equation that v is equal to 5x cubed. That means when we differentiate v with respect to x, we will have dv dx. Okay, so when we have dx here, then that is dv. So you just put dv there and we are good to go. Right, so let's go and differentiate v. So we differentiate v with respect to x, and that will give us 15x squared. Okay, then we would look for the gradient at x equals 4. So that would be, we put in 4 in place of x, and then we get 240. So remember that this is dx dv and this is dv dx, so we will flip it. Right, so we will flip it. This will give us 1 over 240 times dv dt. But what is dv dt? dv dt is 0.5. All right, and then we multiply and we get 1 over 480. Of course, you can rewrite this in decimal. That is also fine.